it up here just so we can see it on the video. What did I say? 8.5?
Yes.
8.5. That's the lesson we're working on today. So we're on page 560. Three-dimensional figures. Well, one of the things I need to help you learn is how to represent three-dimensional figures in both space and in 2 dimensions. So problem 2 says refer to figure 8.7 on page 554. 554. Do you see all these cute little shapes here? I've tried to make one of each other. Whoops, I didn't make a rectangular parallel pipet. I made a cube. Everybody see that?
Mm-hmm.
And maybe I should put it up here so it shows on the video. And what else did I make? I made one of these awful looking things. That's the ugliest thing I've ever seen in my life. Let's see, and if I made it like it looks in the book, I would turn it around where, see what it is? It's a triangle. The middle is a triangle with a triangular pyramid going in both directions. But it doesn't have any particular symmetry to it. That's why it's so ugly. And then, I don't have room for that up here. And then this one, that one came out pretty nice, didn't it? Let's see. Turn it like that. Is that the way it looks in your book? Okay. And can you see how if you make three-dimensional models of this stuff, just get paper and start cutting and taping and putting it together, it'll help when you're teaching this. Oh, and the other one, here's this chunk of cheese. Okay, so now what are we supposed to do? Problem 2, refer to figure 8.7 on page 554 and repeat problem 1. So, name the vertices. Now, what are vertices? What are the vertices?
Are they the points?
Those are the points. Those are the points. The corners or the points, whatever you want to call them. And then what else are we supposed to name?
The edges.
The edges. And what are the edges?
The lines.
The lines between the points or between the vertices.
Yeah.
You see, a lot of math is just learning vocabulary. And when you're helping little kids learn this stuff, you go, I just have to help them learn the words, and then we don't always have to. Vertices is not a common thing, but points are, or corners or that kind of thing. So you find names for them, but you help them also say, now this is the name we're using for it, that the book is going to call it vertices and edges. And they want us to do which one? Figure 8.70. 8.70. Where did it go? Oh, that's this cheese. Okay, that's the one I'm holding here. So that's this little wedge of cheese. So see what happens is, I'm holding this thing up here, and can you see where I don't have any labels on it? So if you look at the picture on page 554, and you look at what I'm holding up here, what would be the vertices?
A, B, C, D, E, F.
A, B, C would be the bottom ones, wouldn't it? A, B, C, You follow that on page 554? The one down in the corner of the page? And D, E, F, the little points up at the top, D, E, F, those are the vertices. Then what are the edges? And it helps if you think through it systematically. So let's take the bottom where we started. What are the edges on the bottom? From A to B, and B to C, and A to C, or C to A, it doesn't matter which way you name it. And so then let's name the top edges, and that would be what? D to E, E to F, and F back to D. Then let's name the vertical edges, and what would those be called? C to F, A to D, and B to E. Everybody follow that? Looking at that picture? That's what you're doing. You're just teaching kids how to name these parts. Well, refer to figure 8.69D and name the left hand back face. 8.69D, that's this one. And they want you to name, now let's see. Okay, see, I'm holding it like it is in my book, which means if I turn it around, see if this is right. Tell me when I'm holding it like it looks in your book. Is that the way it looks in your book?
Mostly, yeah.
Is that it? Okay. Now, what do they want you to name? Name the what?
Left hand back face.
The left hand back face. So when I'm looking at that, I'm saying, what do they mean by the left hand back face? Well, are there two back faces on that thing? I mean, from looking at it, am I holding it the way it looks in the book there? Are there two back faces? This one. Okay, wait a minute, I'm not holding it right, am I? Because the two back faces, yeah, that's right. The two back faces are this one and this one here. You with me? Am I holding it the right way, the way it looks in the book?
Yeah.
The two back faces are this one and this one over here. Now the question is, when you're looking at that, which one is the left-hand back face? This one or this one on this side?
So.
That one? Which would be what shape?
Square.
A square, it looks like, or a rectangle. And what would be the vertices that identify that rectangle? The four corners. A, and then what? If we're talking about this part right here, what are the letters for that part right back there?
D.
A, D, H, E. Everybody see that? Good. Then we're on our way.
If I look at it for too long, it's like
What?
and then I can't tell.
Number 6. In each, make a sketch. Okay, now I'm supposed to teach you how to make sketches. So number 6, sketch a triangular prism surmounted by a triangular pyramid with the top base of the prism the base of the pyramid. You know what a triangular prism looks like? Is that a triangular prism?
Yeah.
Okay, let's see if I can make one of those. Let's see. I'll put Okay, I think the first thing I'm going to do, watch this. I'll turn it and I'll try to draw these, what? These three edges here. You follow me?
Mm-hmm.
Then I'm going to connect the edges, and there's the triangle on the bottom. And then I'm going to connect the edges on the top, parallel lines. And then, why did I make that dotted?
Because it's behind.
Because it's where you can't see it. You follow that? You use dotted lines to show the part you can't see. Now, so I've got it tilted kind of funny where you can see the bottom of it here.
Mm-hmm.
If you didn't like that, watch me mess with your head.
This is so unnecessarily complicated. Yeah, like you're just trying to trick.
Let's see, am I getting it right? No, I don't think so. Let's see, that's the back, because this is the back, so this is dotted too. And what do we have now? This is solid, and this is solid. See what I just did?
Mm-hmm.
And when you go back and forth between those two, it hurts your eyes.
Mm-hmm.
I mean, it creates pain in the brain. Doesn't it?
Yes.
I mean, because it's like I'm switching the perspective on it. So now, it doesn't matter which one I'm using, but what am I supposed to do with this triangular prism, number 6? What am I supposed to put on top of it? A pyramid? Is that what it says?
Mm-hmm.
So, I put a dot up here to make a pyramid. You see that? And here's the base of the pyramid, and I have a line coming like this, and a line coming like this, and a line coming like this. Let's see, what would that be like doing? Okay, it'd be similar to taking this cube, watch this, and putting this pyramid on top of it.
Mm-hmm.
Except I don't have a cube I'm putting it on. I have a triangular prism. Do you follow what's happening there? When you're making those sketches?
Could you explain what a convex polyhedron is?
A 6-sided polyhedron?
Mm-hmm.
You're looking at number 7?
Yeah, and I don't know what the convex thing means. Also, I don't know what a parallel thing
Parallelepiped?
is. Yeah, that
Yeah.
thing.
Okay, and it's not a parallelepiped. Isn't that what it says?
Yeah.
So that means that, okay, that means the sides are not all parallel.
Oh.
Okay.
And a 6-sided polyhedron that is convex, that means all the sides, it's going to have 6 sides, 1, 2, 3, 4, 5, 6, but none of them are going to go, it's not going to go 1, 2, 3, 4, 5, 6. Convex as opposed to concave.
Oh, okay.
Okay?
I see. So,
What does the convex part mean again?
So
you said that.
that is convex, so it's that one.
Oh, I see. Not concave.
but aren't we drawing 3-dimensional figures though? Would it look different then? Because it has 6 sides?
But if it's not a parallelepiped, then that means the opposite sides are not going to be parallel. Let's look at page 554. See what 554 says about a parallelepiped. A cube is a rectangular parallelepiped. And they want this one to not be. Isn't that what they said?
Yeah.
It's not a parallelepiped, which means that this little six-sided shape for the bottom, if I have another one for the top, it's not going to be the exact same shape, so the lines going up and down aren't going to be parallel, that connect it. In other words, the one on top might be a little smaller. And then when I connect these lines, see what happens?
Mm-hmm.
See the ones in the back that you can't see? See how it's like it's kind of, can you see it's got a big six-sided figure at the bottom,
Yeah.
and a small one at the top, so the sides are all kind of going up at an angle.
Okay.
And number 8, an 8-sided polyhedron with triangular faces. Eight-sided. If I wanted to make a model of that before I sketched it, you know what I would do? I would cut 8 triangles and then start taping them together. An 8-sided polyhedron. Okay, so instead of 6 sides, 1, 2, 3, 4, 5, 6, now we're going to have how many sides? Eight. 1, 2, 3, 4, 5, 6, 7. Well, that's not getting it. 7, 8. Okay. One, 2, 3, 4, 5, 6, 8. 1, 2, 3, 4, 5, 6, 7. I need one more in here, don't I? Okay, let's come out like this, and then let's go up here like this, and down here like this. 1, 2, 3, 4, 5, 6, 7. Now I have 8 sides, but I want triangular faces, so I put an X up here and just draw lines to all of these. See what's happening?
Mm-hmm.
And I'm creating triangles for the faces. Okay, number 10. A pyramid has a rectangular base. That would be one of these. See that rectangular base pyramid? Hold it back here where the camera can pick it up, okay. And what's it say about it? Suppose the edges of the base and the height of the pyramid are all doubled. What happens to the volume? Okay, what's the formula Let's see if I can sketch this thing up here, this little picture. Make me a square. And then put a dot up here. And then draw points to all of these. Maybe move this one out a little more. There. Okay, and then, whoops, I want to change that to blue. Sorry about that. Okay, here's my dot up here, and then one here, and then one here, and one here, and one here. And I guess we'll make this dotted back here where you can't see it, which means you can't see this one either, can you? Everybody follow what I just did? How you put the dotted lines there to kind of show what you can, what's in front and what's behind. Now, how do you find the volume? Do you know the volume?
Length times width times height, right?
The volume equals
Would
what?
it be
What's the volume of this?
third?
Huh?
Would it be a third length times width times height?
It's 1/3 of the area of the base times the height. And the height is from here up to here. That's the height. Okay? From the center of the base up to the top. So what do they want to know? What's the volume? If this is 3 by 3 by 3 by 3, then, and this is, let's see, let's go 12 for the height. Let's change that to red so we'll see the height is 12. So the height is 12, and it's 3 by 3 by 3. So the volume would be 1/3 times 3 times 3, the area of the base, 9, times the height, 12. Everybody follow what I just did? For this one I just made up here. Now, what do they want me to do for problem 10? They want me to double it to make it 6. Is that right?
Yeah.
By 6 by 6. And then what do they want me to do to the height? Do they want the height doubled too?
Double that as well.
So that would be 24. Why are these red ones not working very good? I don't know. Get a green one out. Use that one instead. So what would be the volume of this one? 1/3 times what? 36 times 24. Everybody follow what I'm doing? I just picked some numbers. So 1/3 times 36 is what, 12? What's 12 times 24? You have your calculator handy? No, but I do. 12 times 24 is 288. So the volume here is 288. And what's the volume here? 36. So what happens to the volume if I double those dimensions? What's 288 divided by 36? Any idea what it is? 8 times. The volume is increased 8 times when I double it. Now that shouldn't surprise you, because watch this. If I take 2 times 3, and if I take 2 times 12, then this is going to be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. See how it ends up increasing the volume 8 times?
Yeah.
Good. Problem number 12. A rectangular solid is constructed by putting together two cubes, each of age of x. So here's one cube, and here's another cube. And what's it say to do with these two cubes for number 12? Two cubes. If the number of cubic feet in the total volume is equal to the number of square feet in the total external surface area, what's the volume? So if I take these two cubes and I stack them together, and how long did it say each side was? X. Let's see if I can draw this one. I don't know who taught me this years ago, but it's kind of a slick little trick for making cubes. Here's a square, then make another square right there, and then connect them. Is that kind of slick? And then these become the dotted lines back here. Okay? Then I need to build another one on top of that. So what do I need to do? I need to come up here with another one that's this tall and this tall and this tall and this tall, and then this is parallel here. This comes across like here. This goes back up like this, and this back up like this, and this is dotted. And now this is dotted, because you can't see that back behind there. Everybody follow what's happened? And what does it say the dimensions are for this thing? X. So this is X. This is X, this is X, this is X, this is X. These are all X's. Now, if you don't like using X's, you could put a number in there. But if the number of cubic feet in the total volume, so what's the volume of this thing? Volume equals what?
Base times width.
The area of the base times the height. So what's the area of the base? X squared, right?
Mm-hmm.
And the height is 2x. So there's the volume. 2x cubed. Everybody see that?
Mm-hmm.
Now, what else are they asking? And the total surface area. The total surface area. Okay, how many surfaces do we have here? The front, the side, the back, and the other side. Is that right? That's 4. The bottom, that's 5, 6, 7, 8, 9, 10. So it looks like I have 10 surface areas, and each surface area is what? X squared. Everybody follow that? 4 around, and 4 around is 8, and the top and the bottom, because that middle one doesn't show, it's not a surface area. So now, if this is the surface area, and that's the volume, what did it say for problem 12? if the number of cubic feet in the total volume is equal to the number of square feet in the external surface area. So that means they want me to say 2x to the third equals 10x squared. Everybody follow what I just did? So that would, I could divide both sides by 2, and I would get x to the third equals 5x squared. Divide both sides by x squared, and I would get x equals 5. So what would x have to be for this statement to be true? 5. 5 times 5 would be 25, times the height, 10, that would be 250. And the total surface area, each of these would be 25. 25 times 10 would be 250 again. Everybody see that? Just checking it out. Number 14. A cylindrical can is to have the area of its curved surface. So now we have to draw a cylindrical can up here. Okay, did anyone teach you someplace in life how to draw a cylindrical can, a 3-dimension on a flat surface? Well, watch what we do. We make a little oval for the top and a little oval for the bottom, and then we connect the sides. And then this is the part you can't see. Everybody see what I just did?
Mm-hmm.
Okay. So now, what are we supposed to do? The area of its curved surface, that would be, the area of its curved surface, that would be, if I spread it out, that would be this area here, wouldn't it? If I cut the top out of it and cut it down the side and stretched it out. Number 14, the area of its curved surface equals, this area equals what? The sum of the areas of its what? Of its base and top. So that means this equals these two circles added together. The top and the bottom. Everybody follow that? What they're saying is that this area here equals these two areas added together. So does it tell us anything about it? What must be the relationship between the height and the diameter of the can? Well, if we're doing area, this is the height, and what's the length of this rectangle? If this is h, let's call this r for the radius, because isn't that what we're going to use to find area? The area of the top is pi r squared, isn't it? The area of a circle is pi r squared. And so the area down here is pi r squared. And this is the circumference of the circle, isn't it? So what's the circumference of the circle? Circumference is pi times the diameter, which is pi times 2 times the radius. So the circumference is 2 pi r. So this is 2 pi r. Everybody see what I just did? And this area is h times 2 pi r. And what is it telling us? And this is pi r squared. And this is pi r squared. And they're saying this is supposed to equal that. So if I come back here and do the math, and I go h times 2 pi r has to equal 2 pi r squared. See why? Because I have this one, I'm adding them together, so I have to have 2 of them. Then divide by 2 pi r. Divide by 2 pi r. And h has to equal r. So in order for this to work out, the height has to equal the radius of the circle. The radius of the top of the can. Wasn't that fun? The base of a prism is a triangle. Do I have one of those? Aha! Oh no, that's a prism. Yeah, I have one. The base of a prism is a triangle. Number 16. And the base is 3 feet. And the height is 4 feet. So, the triangle that makes up the base of this little wedge of cheese is, let me turn it over like this. The base is how many? 16. The base is 3 feet, and the height from the center up to the top of the triangle is 4 feet. Maybe I better put that up here. I've got this little triangle. The base is what? 3 feet. And the height of this triangle is 4 feet. And this triangle is like a wedge of cheese. So we've got it going up like this, up like this, up like this. And we've got another piece up here. And let's see. If I'm looking at that, then that means I can't see this back here. Everybody follow that? So I've kind of turned it, what I've done is I've kind of turned it on its side, where I've got the triangle here and the parallel lines going up like so. Everybody see how I've kind of tried to draw it here? So now what am I supposed to do with this thing? And the prism is 5 feet high. So that means this length here is 5. These parallel sides are all 5 feet tall. What's its volume? How do you find the volume of a How do you find the volume of this shape here? How do you find the volume of something with parallel edges? A parallelepiped? Okay, what if it was just one of these boxes? How would you find the area? The base times the height, right? The area of the base times the height. So that's the same thing here. What's the area of the base times the height? The height is 5. What's the area of the base? Remember, the base is a triangle. That's 3 by 4. What's the area of the base?
6.
6. Right? Because the triangle, the area is 1/2 the base times the height. So what's the volume of this thing? 5 times 6 is 30. Everybody see that? Good. Number 18. A convex polyhedron consists of two pyramids with a common base that's an equilateral triangle. There it is. I have an equilateral triangle for the common base. It might not look like it, but I think 5, 5. Sure enough, the little triangle where these things hook together is 5 by 5 by 5. Now, what does it say here? Oh, except in this one, they want it 3 inches on each side. So this little triangle that I have in the middle of this thing, where did I put the eraser? This little triangle is 3 by 3 by 3. The height of one of the pyramids is 2. So one pyramid is 2 inches tall. From here to here is 2. And the other pyramid is 4 inches tall. From here to here is 4 inches tall. See what's happening? I've got this thing in the middle. I'm coming out this way, and I'm coming out the other way. And if I drew the pyramids, this would hook up like this. See that? And then the green would be going the other direction. Okay? Now, what do they want me to do with this thing? What's the volume of the polyhedron? How to find the volume? Okay, what we have here is a triangular base. And up here, a pyramid. What's the formula for the volume of a pyramid? The volume of a pyramid is what?
1/3 times the area of base.
The capital B, the area of the base,
The height.
times the height. Everybody see that? So what's the area of this little triangle here? This base. If it's an equilateral triangle, that's 3 by 3 by 3. Then the area would equal what? 1/2 base times the height. And there's the height. Agreed? Everybody agree that this is the height of this little equilateral triangle? So if, and since this is equilateral, that means this is 1.5. And this is 3, and this is, I don't know what it is, but whatever it is, it'll be a right triangle, won't it? So that h squared plus 1.5 squared will equal 9. 3 squared. What's 1.5 squared? Equals 2.25? 2.25. So 9 minus 2.25 equals the height squared. So that's what? 6.75 is h squared. Did I do that right? 9 minus 2.25, 9 minus 2.25, 6.75. What's the square root of that? 2.598, 2.6. So the height is 2.6. So the area is 1/2 times, change colors here, 1/2 times 3 times 2.6. See what's going on? .3, that would be 3.9 would be this area. So now this base is 3.9, and one height is what, 3? So now I've got two pyramids to find the volume for. And what's the formula for the volume? 1/3 the area of the base times the height. So that would be 1/3 times 3, which would be, so one of them, this one would be 3.9, and then 1/3 times 3.9 times 4. And what does that come out to be? Well, that comes out to be 1.3 times 4 equals 5.2. So 5.2 and 3.9 would be 9.1 would be the volume. Okay, in problems 21 to 24, use the approximate value of 3.14 for pi to find the volume and the total surface area of a circular cylinder of given radius and height. A circular cylinder, that would be that can again. And here it's dotted down here. And what does it say for number 22? The radius is 10. And the height is what for problem 22? 6. And what's the volume for a circular cylinder? The area of the base times the height. And what is the base? The base is a circle. So what's the area of that circle? Pi r squared. And since r is 10, this area here is 100 pi. Everybody follow that? So the area of the base is 100 pi times the height. So the volume is 600 pi. And then use 3.14, so take 600 times 3.14. Oh, and the total surface area? Okay, let's come over here and do total surface area. All total surface area is are the two circles with the top and the bottom and the side. You follow that for the total surface area? So what's the area for the top, 100 pi, 100 pi. And what's this? This is going to be 6 by the circumference, which is, circumference is pi times diameter, or pi times 2r. So this would be pi times 20. So this area would be 120 pi. So the three added together, 100, 200, 320 pi, would be the total surface area. Everybody follow the thinking there? Okay, number 26. Find the volume of a sphere of radius 12. That would be a basketball with a radius of 12. That would be one of these little globes with a radius from the center out to the edge of 12. Do any of you know the formula for finding the volume of a sphere? Where is it? You'll have to have this stuff in your notes for the test. 4 over 3 times pi r. Did it say cubed?
Yes.
Yeah.
Is that what it said? You go, I don't like that. Well, write it down and say, I don't like it, but it's still true. So if I want to know the volume number 26, the volume of a sphere where the radius is 12, so r is 12, so that's 12 to the third times pi times 4/3. What's 12 times 12 times 12? 12 times 12 is 144, times 12 is 1,728. 1,728 times 4 divide by 3, 2304 pi. There's the volume of the sphere. 2,304 pi. And if they want you to work it out, then use 3.14 for pi. A grain silo. Farming has come back to me. A grain silo. What does it say about this grain silo? What kind of shape is it? A cone. So I've got a cone down here in the bottom. You follow me? So the grain will pour out at the bottom. With a cylinder on top. So it goes up like that. Okay. And it looks like this is the part I can't see. And I can see the top coming down. All right. And what does it tell me about it? The diameter is 10. So from here to here is 10. Which means the radius is 5. Agreed? And it's 30 feet high. And what do they want to know? How many cubic yards of grain does the silo hold? Cubic yards, that would be volume, wouldn't it? So what's the volume of this top part? The area of the base times the height. The height is 30. What's the area of the base? What's the area of a circle? Pi r squared. So the base would be 25 pi. Everybody follow that? That's the volume of this part right here. What is that? What's 25 times 30? 750? Now I need the volume of this little cone. What's the volume of a cone? 1/3 the area of the base times the height. Did they tell us how tall this cone was? Yeah. From here to here is 10 feet. So the height is 10. And the base would be the area again, 25 pi, and 1/3 of that. So 250. So the volume of that cone would be what's 250 divided by 3? 250 divided by 3, 8.3. 8.3 pi. So 750 pi plus 8.3 pi would be 758.3 pi. Okay, what are we doing now? Number, let's see. Okay, number 30, it's back to using spheres again, like those globes. Oh, wait. That's 758.3. That's cubic feet, isn't it? And they want cubic yards, so I have to divide this by what number? How many cubic feet in 1 cubic yard?
9.
That's right, 9. Divide that by 9. And if little kids have trouble seeing that, just draw them. And go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. See what happens? 1 yard is 1, 2, 3 feet, and 3 feet by 3 feet by 3 feet is whoa. Cubic yards, 9 square feet, but cubic would be, divide that by what? 3 times 3 times 3, 27. Everybody see that?
Mm-hmm.
Area would be 9. Volume would be 27. Okay. Number maybe we ought to do number 32 and then stop when you get to 35. An ice cream cone is 7 centimeters in diameter and 10 centimeters deep. There's a picture of it. The inside of the cone is packed with ice cream, and then a hemisphere of ice cream is put on top. How much ice cream do we have? Ice cream weighs 1/2 gram per cubic centimeter. So what's the volume of the cone? 1/3 of the base. 1/3 of the area of the base, which would be, if the diameter is 7, then the radius is 3.5. So that would be 3.5 squared times pi times 10, the depth of the cone, times 1/3, and then add that to the hemisphere, which is half of a sphere, And what's the volume of a sphere? 4/3 pi r cubed. So you take 4/3 times pi times 3.5 to the third power, and then take half of that because it's only half of the sphere. Add those two together, and then how many grams of ice cream? You have your total volume, which comes out to be 218, and so the grams would be 109 because it's a half a gram per cubic centimeter. Wow. So do you see any of them that you're going to have trouble with? That you want me to help you with, odd or even? 35, drilling holes in a bowling ball. Do you understand that you take the volume of the bowling ball, then you just take the volume of the holes where you drill them and subtract that from the total volume of the bowling ball for number 35. You get the weight of the total bowling ball, and then you subtract from that the stuff you drilled out. The 3 cylinders that you drilled out. Any other questions from any of those problems?
How do you find the surface area of a pyramid?
The surface area of a what?
Pyramid.
Of a pyramid. Let's see, what kind of pyramid?
One with a square base.
A square base? Ah, here it is. Okay, now would the area of the base be considered surface area, or would it only be the 4 sides?
I don't know. I'm referring to problem 13.
13?
When it was the total. Oh, so it wouldn't be the area of the base. It's just the total external surface area.
Well, look what it says. A solid consists of a cube surmounted by a pyramid. So what we have here is a cube with a pyramid on top.
Yeah. It says that the height is 4x, but how do you find the surface area of it?
The base is the top of the face of the cube, and the height is 4x. So you've got the volume, right?
Mm-hmm.
Now you need the external surface area.
Yeah.
What's 4x? Oh, the cube is 6x. Whoops. I'm telling you, some of these markers are just not working much anymore. Okay, so this is 6x, right?
Mm-hmm.
And what's on top of it? This pyramid. Okay. And what does it say about that pyramid? The height of the pyramid is 4x. Isn't that what they're saying? From here up to here is 4x. Is that what it looks like they're saying? And I want to find the surface area, which means I have to find the, okay, these areas here are just going to be, what, 36x? 1, 2, 3, 4 of them.
Mm-hmm.
Now the other thing I need are the areas of these little triangles that are what? 6x by 4x height, right?
Mm-hmm.
And I want the area of that triangle. And how do you find the area of a triangle? 1/2 the base times the height.
Mm-hmm.
So that would be 1/2 times 6x times 4x. So that would be 12x squared. So each of these little things here is 12x squared. Wouldn't it be?
Mm-hmm.
And I have 1, 2, 3, 4 of them. 48x squared.
Thank you.
And I'm assuming they're not counting the base as one of the surfaces.
No, because they wanted the external.
They just want those 4 and then the 4 little triangles. Any others that you have a question about?
When we meet again on Tuesday next week, can I turn in my 8.4 homework then?
Sure, that's fine. And we don't do 8.6. Did you notice that on assignments? Is 8.6 is not listed?
Mm-hmm.
I mean 8.5.
What?
We're doing 8.5 today.
Oh yeah, 8.6. It says skip 8.6. So that must mean that we're ready for, and skip 8.7. So we're ready for the practice test on Tuesday.
Okay.
So next Tuesday we'll do the practice test, and guess what that means next Thursday? We'll take an exam over chapter 8. Okay? Well,